Okay, last video on curve sketching. So we're thinking about our window. We need no real negative x-axis. We'll draw some, but we don't need a lot. And our y's really don't start of being interest until around -10. So, not giving myself much negative x-axis, so I didn't give myself much negative axis, and didn't give myself much positive y-axis. Then we need to go to 13, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And truthfully, I probably have spread those out a little bit too much. I probably need more space over here, but I've already gone with it. And then I'm just going to do this. I'm going to call that -10. As long as you label so that your reader can understand what you've done, that's fine. So I'm going to call that -10. Then I'm going to say that's -10.1, -10.2, -10.3, -10.4. And that's going to allow me to have the detail that I need to really show what's going on. And as long as you label, that's fine. Now let's plot what we know. We know that we have a vertical asymptote at x equal 1. And I'm going to plot that, just because I can, in green. There's my vertical asymptote. And when we found the vertical asymptote, we said that we were going to go up on either side. So on my vertical asymptote, since I know I'm going to go up on either side, I'm going to put that information in there. We have a horizontal asymptote at -10. There's my horizontal asymptote. Now what horizontal asymptotes, and pretend that's a straight line, they tell you where to begin and end. That's what horizontal asymptotes tell you, where to begin and end. Then the other things we found, a local minimum at 9, -10.312. So let's go out a little bit. There we go. -9 or 9, -10.32. Maybe right about there. That's a minimum. And an inflection point at 13, -10.2778. So maybe right about there. So now it's time to connect the dots. And here's the order that we're going to go through. My beginning, then here 2, 3, 4, 5, and 6. That's how we're going to work our way through it. Now you certainly aren't going to let, you don't have to number the things like that, but that helps us connect things up. Now I got to look at my chart to see how I'm going to get started. Look at your two charts. So my first chart said from the left, -infinity to 1. From -infinity to 1, I should increase. And from -infinity to 1, concave up. So that's telling me how to start. On the very left, -infinity, all the way to 1, you should be concave up. From -infinity to 1, increase. So from my asymptote to 1, from position 1 to position 2, increase and concave up. So something that looks like that. I pick up my pen, I go to the other side, because you never cross or touch vertical asymptotes. So now I'm on the right of 1. So look at your charts again. On the right of 1, so there's 1, there's the right of it, I should decrease. And there's 1 on the right of it, I should be concave up. So once I go past 1, when I get to the right of 1, I should be concave up and I should decrease. So that tells me how to go between the next two locations. So from location 3 to location 4, decrease and concave up. And then your points are going to guide you. It's a minimum, so draw it as a minimum. I go to my inflection point. At inflection points, concavity changes. I'm currently concave up. I change to concave down. I'm currently smiling, change to frowning, and head towards that asymptote. And here's where I said I probably didn't give myself enough room. I don't have enough room to show it really getting close to that asymptote. Again, that's about that extreme left and extreme right thing. You know, if I kept counting here, it looks like maybe I'd get to 20. Well, 20 is hardly the extreme right. But as long as you make it look like you are going to eventually get up near that asymptote, that's good enough. And there's my graph. And if all the pieces fit together so that you can make your minimum look like a minimum, make your inflection point look like an inflection point, if all the pieces fit together, you are almost certainly right. But we can and will check this on our calculator. Again, it tells me to get new batteries. So I've already put it in the calculator. If I just hit that standard window, which we already know is not a particularly good window here, but if I hit the standard window, I can at least check part of it. So I can check that it starts out near -10. Remember, your standard window goes from -10 to 10. So it's down by -10, goes up to what looks like an asymptote. Now, it doesn't look like it's totally getting to 1, but if you envision that it kept going over, it looks like it would get to 1 and have an asymptote. And then it comes to the other side of the asymptote and comes down. And so really, on the standard window, I was able to check all that. Now, on the standard window, that part of the graph actually checks. And if I was running out of time and that's all I could check, I would check that. I would feel pretty good about it. That the standard Zoom 6 window, -10 to 10, really does check that very well. What it doesn't check is the part down here. So now we will think about checking that part. And we will give it the numbers necessary to check that part. So it looks like this part starts somewhere before 9 and goes a little bit past 13. So I'm going to press window. And so let's start at maybe, 6. That's before 9. And then we want to go past 13, so maybe we will go to 20. That should check this part in here. So I'm starting at roughly 6 and going to 20. So that's certainly going to check that part. And now my y's. Let's start at maybe -9.9, just a little bit before that -10. And let's go down to maybe -10.5, except I got those backwards, excuse me. So the minimum, -10.5, I got those backwards. So going down to -10.5. And let's go just a little bit higher than the -10. So let's go -9.9 and count that off by 0.1. So again, I really am mimicking what I want to check here. I want to check this portion of the graph. And so I started right about 6. That'd be good enough. You want to start a little bit sooner. And then y-axis, just that. I gave it those numbers and then press graph. And it turned itself off because, oh no, there it's going. Where's it going? I think my calculator died. Let's try turning it off and turning it on again. My calculator died. I'm not going to do a whole new video because my calculator died. Let's see if it'll do it now. Graph. Oh, it's thinking about it. You can just barely see it up in the corner there. It's thinking about it. And there I start seeing it. Now, it's not as exaggerated, but it's coming down, hitting a minimum right about there, and it's starting back up, and right about there, it looks like we have an inflection point. If I do a trace, and I tell it to go to 9, that indeed is the minimum, and it says down there, if I zoom in, maybe you can see it. it says negative 10.3125, that's what we had. Do another trace, go to 13. That does look where there's an inflection point where it's going concave up to concave down, and it gives me that same value again. And so now I have checked that looks reasonably like this. Mine's a little curvier than theirs is, but it looks reasonable. And so I feel that I have got it. But I didn't know what the real shape of this was until I did all this work. Back on the standard window, you didn't see this detail at all. And what I'm going to be looking for on a test is a good detailed graph that shows me this information. If you show me a graph that basically looks like the standard window, you're not going to get any credit. It turned itself off. I really got to remember to get new batteries for this thing. Yeah, well, I'm not going to be able to show you the new window because it keeps turning itself off. But come test time, if you show me a graph that looks like the standard window and doesn't show me the detail that we calculated, you're just not going to get much credit. You show me pretty graphs. And that is the end of this section.